Okay, now it's recording. Okay, a cell of EMF 1.5 volt and internal resistance 1 ohm maintains a constant current of 0.5 ampere in an external circuit. Okay, in an external circuit. When an electric charge of 2 coulomb, okay, flows in the external circuit, calculate what? Calculate the thermal energy dissipated from the cell, energy dissipated from external circuit, and total energy supplied by the cell. Okay, so okay, what we have the EMF over here, we have the internal resistance, we have the current, external circuit. So electrical charge, this is the Q flow in the external circuit. Calculate the thermal energy dissipated from the cell. Class, energy dissipated from where? From the cell. Why there is energy dissipated? Why there is energy lost inside the battery? Why? This one refer to what? Energy lost through what? Sorry? Cannot hear?
Internal resistance.
Yes, because of because the battery got internal resistance in the cell. Yeah. So got energy loss. Dissipated means loss. And then energy dissipated from where? External circuit. This one. So just now is the internal resistance R. This one small r. Just now is small r. This one is external external resistance. Yeah. So long. External resistance, which is called capital R lah. Okay. External resistance, energy dissipation, and then total energy supply. Total supply. So this is the refer to the EMF lah. Okay. Okay, now let's do it. Let's do the question. Question A. So how to find? So energy formula is what? So if we are talking about resistance, then you use the I square RT lah. But this one is energy loss inside the battery. So using the small r. I square RT. Energy inside the battery. This is the one lah. Okay. So current, do you have current? Yeah, you have 0.5 square. Internal resistance is you see, internal resistance 1 ohm. What's the time taken? Where's the time taken? When electrical charge of this one flowed in the circuit, calculate the thermal energy dissipated. So electric charge. That means we can find time lah. Understand? Q equal to IT. See, because this is the total charge that flows in the circuit. Total charge that flow. So the current is this. So we need to find, you know, for this amount of charge, how much time has taken? How much time has taken for the current to accumulate until 2 coulomb? Yeah. So the 2 coulomb, this one current is 0.5 ampere. You can get a time. So the time is what? Divide 2 by, is it 4? Yeah.
Yes, sir.
4 seconds. Yeah, 4 seconds. So 4 seconds has passed. So 4 seconds has dissipated. 4 seconds is the time. So let's calculate. 0.5 square multiply 4. So I get 1. So I get 1 joule. 1 joule is lost inside the battery. Yeah, this 1 joule is lost inside the battery. Okay. This one lost in the cell. Okay. Now, how about energy loss in the external circuit? That means energy loss through the external resistance. So that one also use, normally for energy loss we use I square R lah. Normally energy loss we use got resistance one, yeah, resistance variable. If energy supply we use the VIT, yeah, VIT. Yeah, this one energy loss also, but in the external circuit. So that means I square capital RT. Understand? So current is 0.5. And then R, capital R is, we have capital R. Don't have, but we have EMF, isn't it? It gives us the EMF, that is to find the external resistance. We have the current R plus small r, correct not class? 1.5, current is 0.5 ampere. So external resistance plus internal resistance 1 ohm. Correct not? So 1.5 divided by 0.5 is 3. And then minus 1. Minus 1. So the answer is 2. My external resistance is 2 ohm. So it's 2. Time taken. How much time is taken? 4 seconds just now, right? 4 seconds. So, okay, let's calculate. 0.5 square multiply 2 multiply 4. So the energy loss in the this one is energy loss where? Loss in circuit. So you should write in external circuit lah, external resistance lah. Loss in external circuit. It loss in external circuit R. 1 joule loss inside 1 joule loss inside battery, 2 joule loss in the external circuit, outside the battery. Inside battery, outside battery. So now, can you calculate the total energy supply? Of course, it's supplied for these two energy, right? So it's 3 joule lah. Okay. Question C. So energy, of course, energy supplied by battery or by the, by the cell is of course equal to energy loss in cell plus energy loss in external circuit. Betul tak? In external circuit. Which is external circuit. So it's actually, class, kamu tengoklah macam ini, kamu tengok saja. EMF ialah IR plus R kan, kelas? Betul tak, kelas?
Betul, sir.
Betul.
E equal to IR plus IR, betul tak?
Betul, sir.
So kalau you multiply current both side, kan dia menjadi I square R, I square RT, I square R, betul tak? This is a power, this actually is power supply by cell, by battery lah, equal to power loss in external circuit plus power loss inside the cell. Okay? EI is VI, you know that? VI. This I square R, power loss in external circuit. I square small r is power loss inside the cell. And then you multiply with time again. Then you get what? EIT I square RT I square small RT. So this is what? Energy lah. Just now is power. So you multiply time, you get energy. You get energy. That means apa maksud? Maksudnya ini semua energy. Is energy. Energy supplied by cell. Energy loss. Energy loss out. Energy loss outside. Energy loss inside. This one is for energy. This one is power. You see, actually this formula come from the general formula that we know, the formula that you learn in SPM, E equal to I R plus R. Okay, so what I'm trying to say is just now energy loss in the internal resistance. In the internal resistance is 1 joule. Energy loss in external resistance is 2 joule. So how much energy supplied? Class, how much energy supplied by battery?
3 joule.
3 joule lah. 1 joule is lost inside battery and 2 joule is lost outside, so it's 3 joule lah. Yeah. That's the answer. Yeah. Based on this actually. We already calculated I square RT, I square capital RT, I square small RT. So actually this I square RT and I square small RT, these two plus together is energy supplied by cell, EIT. If you don't believe me, you calculate and see. You can get the same answer, 3 joule also. Yeah, use this formula EIT now. Okay, can you use the formula energy supply? So we also can use the another formula. Yeah, this one also is EIT lah. Let's calculate. Yeah, EIT equal to I square small RT plus I square capital RT. So maybe you can use EIT and calculate. You get 3 joule also. Yeah, don't believe me, you try. 1.5. So this is EMF is 1.5 volt. Yeah, 1.5. And then current is 0.5. Current is 0.5. What's the time taken? Time taken is 4 seconds. Okay, 4 seconds. What's the answer, class?
Three joule, sir.
Yeah, 3 joule. You see that? I told you. It's all actually come from this one formula. All come from this one formula. Then from this formula, you can get the power. Get a power. What is this lah? You can get a power. Can get the energy. Okay, so that's all. All right, class, you okay? What's the time now? 9:30.
Yes, sir.
So okay, that's for this question.